official name is SQL, but I think a lot of people call it SQL. There's a bunch of different versions of SQL, SQL. There's like MySQL and Microsoft SQL, this, and I don't know this. There's different things up there. Okay, we are not going to cover setting up and being an administrator of a SQL server. That's a lot more complicated, and that's not what we will cover in our class. But we will talk about writing queries, okay? And we'll just do it within Python, okay? So in Python, you can write a query and then use Pandas has a built-in kind of feature that will run SQL queries. And so we'll kind of explore running SQL queries through Python and Pandas. That said, if you're in, if you get a job and they say you need to know SQL, you can say, I know how to write queries, okay? And maybe you'll use Microsoft Access to write your queries and things like that. You won't be a database administrator, okay? And SQL is very easy to pick up. You can always type stuff like learn SQL. So I've just uploaded onto my GitHub 2 notebooks, 0901 and 0902 for this week, and a SQL database. Okay, it's a tiny one, 1 megabyte, but it's enough to do the tasks that we want to learn. Okay. And so this is the database, Chinook SQLite.SQLite. There's different kinds of SQL databases. They all kind of use, they're like different dialects of the same thing. And so, we'll cover like the basic SQL queries. And so SQLite's very simple, and in Python automatically can connect to it, or as long as you only need to have SQL Alchemy installed. If you installed Anaconda, SQL Alchemy is already going to be one of the packages included. If you haven't, if for whatever reason you like use Miniconda or something like that, you can just do conda install SQL Alchemy, okay? And this will be a way for you to connect to SQL databases, okay? If you're gonna interview for a job and they say they're gonna put SQL questions on stuff like that on the interview, I would recommend this website, w3resource.SQL exercises. There's like hundreds of little problems here, okay? And you can, it starts off from very simple to a little bit more complex, okay? And they're pretty good, okay? So you would just kind of click this, and the nice thing about all of these things, right? Okay, so write a statement to display all the information of all salesmen from the table salesman, okay? And there's go to the editor, okay, which allows you to just type in the query yourself. So in this case, it would be select star from salesman. That's like about as easiest of a query as you can do, and you'll click submit, and you'll get these results, which indeed line up, with what you're supposed to get. And then the nice thing about all of these exercises is that they all have solutions, right? So you can click the solution, and it will say that the answer is select star from salesman, okay? And here's the output, okay? But then, the nice thing is you can read the statement, and then and you can write the query yourself in this little practice online box, okay? So it's a good setup, and you kind of have to use the website or stuff because you don't want to try to install and set up your own SQL server on your own computer, okay? It's a lot of work, a lot of headaches, for not a whole lot of payoff, okay? Because to even set up the server yourself, you got to set up tables and import data and get all the links set up correctly. It's easier just to work with tables and databases that already exist, because that's most likely the situation. Like if you get hired, that's going to be the situation you're thrown in. They're not going to ask you to set up a database from scratch. They're going to have a database somewhere already set up, and they want to make sure that you are able to retrieve the information via writing queries. Okay, so the important thing is the way you interact with the database is you write a query, right? And a query is basically a search string, right? So you go on Google and you say, how do I make macaroni and cheese, right? And then Google goes out and does this, right? SQL is pretty much the same thing, except it's a very structured language. You have to say, give me select this from this and things like that with these kinds of things. So it's basically you're just writing some kind of search string, but it's in a structured thing. SQL stands for Structured Query Language. So there's a lot of structure built into it. There's a few. One major drawback of SQL is that, well, I don't know about a major drawback, but like maybe it's a design feature, okay, is that there's no missing values allowed, okay? So in an SQL database, you are not allowed to have missing values. So if you have a missing value, you have to code it some way, okay? So it might be like, here's an age variable, and everyone has an age, but then if someone's age is missing, maybe you have to write -99 or something like that, okay? And that indicates to the user that this person's age is unknown. But then you have to be aware, you can't just ask what's the average age in the database, because you're going to have a whole bunch of -99s in there that's going to drastically bring down the mean and stuff like that. So so stuff to be aware, right? Okay. Let me see. Okay. Oh, another place you can mess with is SQL Fiddle, and but this requires that you create a SQL schema. You've got to build something, and you have to probably use text to DDL. And so you would copy and paste like a CSV in here, and then you would, so like if I do like 1, 2, 3, and 3, 4, 5, it's 6, 7, 8. Let me and one more line, A, B, and C. Okay, so then I would click append to DDL, and this would create the table here, okay? And this is written in SQL language, right? Create table 1, insert into table 1 these values, and you'll click build schema, and now you can interact with it. You can now write select A from table 1, okay? And then you run this, and then it pulls out column A, 136 or something like that, right? So you can, so this is another place you can do it. You'll have to like copy and paste your CSV files and things like that, and you can use text to DDL, and it will create basically how you would insert the data values into SQL using the SQL language, okay? In general, you won't be, we as ones who are writing queries to extract information we want, we're very rarely going to use commands like create, okay? There's other commands for drop, which will like just delete an entire table, okay? Very dangerous and risky. Probably if you are working at a company, they will disable certain commands. They're going to say you're not allowed to use the word drop, okay? And your account won't have the rights to use the command drop, because you can break the entire database if you just casually drop some tables, okay? That's, I mean, you just say like drop tables, and then boom, all the tables are gone, okay? Which is, there's actually a comic about this, right? XKCD, I don't know. So there's something called SQL injection attack, okay? And so a lot of forms on the internet, you'll like enter your names and stuff, and then when you write your enter your name, it turns it into a SQL string that will then enter that command into the SQL database, okay? But what you can do is you can, if you say your name is Robert and then you put a closing quote, okay, and they don't do any kind of injection attack verification, okay, then this entire string, Robert, quote, this will like close off the SQL statement, and then the semicolon says I'm going to write another SQL statement, such as drop table students, and that will like delete the entire table called students. And you can do an injection attack this way. I would say most websites do a better job than this, right? But yeah, I hope you've learned to sanitize your database inputs. It's very true. When you have the internet, there are some people who just take delight in breaking things. So okay, anyway, all of this, we're going to just use what's called the Chinook database. I think it's American Indian, Native American type of name for, I don't know. So you got the helicopters, right? I think they're named after the same thing. But anyway, this is how we do it. Okay, we're going to just import pandas first of all, right? And then we're going to take SQL Alchemy and import this thing called create engine. Okay. Import create engine, and then we create an engine. Okay, we use the create engine command to load up our file Chinook _ SQLite.SQLite. Okay, now this works for us because we have this Chinook SQLite file on our local computer. Okay, or if you've at least downloaded it from GitHub, this file will exist on your computer, and you can connect to it that way. Probably, if you work for a company, they'll give you some kind of command that you will use to connect to the server that exists in a different room, right? So it'll have like a web address, kind of a web address, but it'll be like an internal one, probably something on the local intranet, your company intranet, and your IT people will give you the information on how to connect. But anyway, within Python, you just create an engine, and this allows you to run queries, okay? So what we're going to do is we can just verify that indeed we have connected to the database, and we'll just say, give me the table names that exist, okay? So we have the engine is this database, and we're going to do engine.tablenames, and we're going to say, what are those table names, and we get a list, right? And this is like it's like a music store, okay? So they have informations on albums, artists, customers, employees, genres, invoices, invoice line items, media types, playlist tracks, and tracks, okay? So basically, it's like you can imagine this as being I don't know if people ever buy individual MP3s, right? It used to be, I don't know who buys individual album CDs anymore, right? Because everything went digital, and then and you would buy your individual songs, and then I don't know if anybody buys individual songs anymore. We all just have subscriptions to these streaming services now. But anyway, this is, imagine some store running some kind of music shop where they're selling tracks individually, and so you need information about each song, okay? And so that's going to be like the album, artist, and track thing, and then playlists and stuff. And then you'll also have information about customers and their orders. So you'll have invoices. Each invoice might have a different number of things that they've purchased, and then you'll have employees as far as like who's helped who. Okay, so anyway, we'll go ahead and do this. All right, so here's one way to do this is you can do engine.connect, create a connection, and then you're going to execute a query. Here I write my query is select star from album, okay? And this just means select all the columns. The star is the wildcard, basically meaning everything. So select all the columns from album. Now SQL is not case sensitive. I think it's not case sensitive. So I could have written select and from in lowercase, but the general trend is you write your SQL keywords in all caps, and then the tables and the variable names, column names, you capitalize it according to how it's written. Okay, so we're going to just say select everything from the table album. Okay, then we execute this query. Okay, and we do rs.fetchAll. Okay, so this is going to be the query string. We say fetch everything there, and we're going to throw it into a data frame. Then we're going to close the connection, and then we'll go ahead and we'll print out the top few lines of this data frame that we've created. Okay, rs.keys also comes, will produce some results. Okay, so we can say create the engine. Okay, so just select everything from album and the head. This is the first 5 rows of this. And so we have columns 0, 1, and 2. The data frame doesn't have the column names. Okay, so we've got album ID, title, and artist ID, right? And so we have that. Okay. You can also write your SQL command over multiple lines using triple quotes. So we'll say our command is going to be select the last name and the title from table employee. Okay, so this selects the columns, right? And then and to kind of say we want to do this whole thing, create a connection, execute the query, throw it into a data frame, and close the connection. You can use with. Okay, and when the with statement reaches the end of it, it's going to close out the connection for us automatically. Okay, so we can do engine.connect as the connection, execute the command, throw the results, the rs for results, results.fetchAll, throw that into the data frame, also name the columns using the keys. All right, and so when we do that, because the keys pull back the column headings, we can do this, right? And so we have employee Adams as the general manager, employee Edwards, sales manager, etc., etc., etc. Okay. Pandas actually has one command that does everything super easy, right? So this is kind of the step-by-step thing, and you might want to do this individually if, like, I don't know, you want to optimize something and you didn't want to do one particular step, and you can just do pandas, read SQL query, give it the command, give it the engine, right? So the command I've written is select last name title from employee, and the engine I've created earlier using the connection to the SQLite database. Okay, and so this is probably the one we're going to use the most, is pandas.read SQL query, and when you do this, it just does everything. Okay, so all of this stuff, you can ignore these 2 cells, but this is just kind of the manual step-by-step thing. Pandas has just one command that does everything for us, and it makes it really easy. Okay, so pandas read SQL query, boom, automatically creates a data frame for you. It's really nice. Okay, really nice. Okay, so now I'm going to just cover some basic SQL commands. All right, so we've already seen select and we've already seen from, right? So from is the name of the table. Select is the name of the columns you want. And so we have a sort, okay, which is called order by. So you're going to take the results and you're going to order it by whatever columns. First this column, then this column to break ties, and this column to break ties. You can add the options ascending or descending, okay? So it's just another language, okay, to pick up. So here I'm going to say select all the columns from table employee, and you're going to arrange them by birth date in descending order. So the biggest at top, the smallest at the bottom. Okay, so this is the employee table, all right? and this is all the columns. So we've got Jane Peacock, Michael Mitchell, Robert King, etc., and then the birth dates, we've got August 29th, 1973 is the youngest person in the office. Then the next person is July 1st, 1973, and then, you know, keeps going down. The oldest is September 19th, 1947 in descending order, okay? So order by just arranges them in descending order. Is that good? Okay. You can select some of the rows by using a where statement, okay? So all of this is just building up queries that get more and more complicated. So here you want where employee ID is greater than or equal to 6, okay? So already that's going to limit us to, employee ID. We have 3 people, okay? We have Michael Mitchell, Robert King, Laura Callahan, okay? And then we're going to say employee ID has to be greater than or equal to 6, and the title has to be IT staff, okay? And so we have 3 people over 6, 7, and 8, and then we got 2 people with IT staff, so we're going to return these 2 rows, Robert King and Laura Callahan. And we said we want all the rows, okay? I mean all the columns. Select all the columns. From here, we're going to order by birth date, which defaults to ascending order, I believe. Okay, and so we have Laura Callahan, Robert King, arranged by birth date in ascending order, 1968, 1970. Okay, and indeed, title is equal to IT staff, and the employee ID is greater than or equal to 6. Okay, notice we use a single equal sign. Okay, so in pretty much all of your other languages, when you want to limit it to a certain condition and say this has to be equal to this, it's a double equal, okay? But in SQL, it's a single equal. You say, I want where this column, the title, is equal to IT staff. You know what, let me check. Let me see if this is case sensitive. I'm gonna do IT staff, yeah. So when you put it in quotes here, this part is case sensitive, okay? But let me change this. Title, lowercase title, this will still run, okay? So column names are not case sensitive, but when you put it in quotes, it is case sensitive, okay? So I've got, I forget, okay. How do you write comments in SQL? I think you use a % sign. Begin the comment with 2 hyphens, okay. Or the /*, okay. So if you want to write comments, okay, so I think I can write column names are not case sensitive. Yep, okay. But text inside quotes is. Column names are not case sensitive. Text inside quotes is case sensitive. All right. Maybe I should write that somewhere. Okay. You can write comments using a double dash. Okay. Okay. Limit tells you how many rows you want back. Okay. So this is important if you're going to query a giant table, right? So if you've got a table on your server that has, 300,000 rows, and you run the query, it's going to try to give you back all 300,000, and maybe you don't want that. So you say limit 10, and that will only give you back 10 of the rows, and that will speed things up, right? So it's kind of like head. If you just want to check to make sure the query you've written as it is works, you can just say something like limit 10, and just get back a few of these things. So it's kind of like head. So here's all of the things. Select star from album, okay? Album ID, let's see if anybody recognizes any of these albums, right? Okay, so we've got album ID is a number, title and artist ID is a number here, okay? Now, you are not going to be designing SQL databases, but in general, there's kind of a principles of SQL database design, and that is you do not want redundant information, okay? So the reason why artist ID, is not written there, okay? So you can see album ID 2 and album ID 3 both have artist ID number 2, okay? Why didn't we just put the artist name there? Why didn't we just, whatever artist it is, why don't we just write it twice, okay? SQL does not like that because you could, let's say, the title could be spelled differently, right? The artist ID could be spelled differently, right? Like, so one thing you might capitalize all the letters, and the other you might only capitalize some of the letters or something, and you can end up having two different ways of writing the name of the artist, and that would appear as different artists. So to indicate that it's the exact same artist, you use the same ID. You don't want to have redundant information because that just opens you up for making a mistake. I have a low battery. All right, so anybody recognize any of these things? For those about to rock, we salute you. Balls to the wall, restless and wild, let there be rock, big ones, jagged little pill, facelift, Warner 25 años, I think. Plays Metallica by 4 cellos, and Audio Slave. No one recognizes anything. Okay. Well, we'll see who these artists are, right? So we got AC/DC, okay? Except Aerosmith, Alanis Morissette, Alice in Chains, Antonio Carlos Jobim? I don't know. Apocalyptica and stuff like that, right? So, so Except has produced Balls to the Wall and Restless and Wild. AC/DC produced For Those About to Rock, We Salute You, and Let There Be Rock, okay? Big Ones from Aerosmith, so on and so forth, okay? Jagged Little Pill, Alanis Morissette. All right, and so we have these two things, and maybe we want to have the information together, right? So what we have to do is we create a join statement. So you're going to say we want everything from album, okay? Inner join artist, okay? So we're going to join album with artist, okay? So we're going to say we're going to join the table album with the table artist. And how are we going to link that? We're going to use this column name. Artist ID is going to be matched up with this artist ID. Okay? And so if I do that, it produces, it literally joins this table, the album ID and artist ID, with the artists table, okay? The album table with the artist table. And you can see it did match up artist ID and artist ID, okay? Unfortunately, we have like basically redundant, not redundant information, but we have the same column kind of listed twice, which can be a little confusing, but we can see how it has matched up the two tables here, okay? So from here, you can rename some of these columns, right? So now what I'm going to do is we're going to select the column title, and we're going to rename it as album title. Select the column name and rename it as artist name, okay? We're going to pull this, and here it says from album, okay? And it's still, from album, but you have to kind of think of this as from album joined with artist, right? So we're going to take the album table and the artist table and we join them together, and that creates one new table, right? So that's That's what this is, right? So select everything from album joined with artist, okay? And that's what this is. Select everything from album joined with artist. Album joined with artist looks like this, okay? And this column is technically album.artistID, and this column is technically artist.artistID, okay? And here we're just saying we only want two columns. Title, renamed as album title, name, renamed as artist name, and it's going to come from this joint table where album has been joined with artist, where we set the artist IDs equal to each other. We only want the top 10 rows, okay? And this is exactly what we get. Album title, artist name, things like that. Right? Is that all right? Okay, so so this is like I'm introducing a new command here that I haven't even covered, but I feel like the language of SQL is simple enough for you to understand if you've worked with things like dplyr and pandas, right? Okay, so what do you think is going to happen here? We're going to say select artist.artistID, okay? The name, which is the name of the artist, okay? The count of album ID as album count from the table album joined with artist, where we're setting artist ID equal to artist ID. And we're going to group by artist.artistID. So what do you think this is going to do? So we're selecting the artist ID, the name is the artist name, and then we're creating something called count of album ID as album count. That should be a hint as far as what we're doing. Okay? All right, what this is going to do is it's basically going to go through this table, okay? It's going to go through this table. It's going to look at the artist IDs, and it's going to group by, that's what we have, okay? So we have from album inner join artist on this. That's basically this table. And then it says group by artist ID, right? So it's going to create groups here. Okay, it's going to group the rows one. And kind of the summary function is it's going to summarize the count of the albums that it sees. So it's going to say AC/DC, I see 2. Accept, I see 2. Aerosmith, at least in these rows, I only see 3. And Alanis Morissette, I only see 1. And so on and so forth, okay? So it's going to say like AC/DC has 2, and Accept has 2, and Aerosmith has 1, okay? Now, it does the whole table, so these counts might actually be bigger, right? But it's going to give us the top 10 results here. All right, and so that's what we see. AC/DC has 2, Accept has 2, Aerosmith has 1, Alanis Morissette has 1, Alice in Chains has 1, so on and so forth, okay? And so here, we're now starting to get summary values, okay? By combining group by along with the summarizing function. Okay, so here's kind of a list of SQL aggregate functions. Okay, you have average, count, min, max, and sum. And let's see, introduction. So these will use aggregate functions kind of with things like group by in your selecting, right? So the most commonly used ones are average, count, min, max, and sum. Average being the mean, okay? And I think there's there might be a few others, but these are kind of the primarily used ones. Your summary or aggregate function there. Okay. Select everything from album, order by artist ID, limit the top 15, and let's just kind of see. And indeed, if we see the artist ID, we have 2 for 1, 2 for 2, 3, and we can see indeed Antonio Carlos Yolbeam has 2, and Audio Slave, which is album artist ID 8, has 3, okay? If we ordered these by artist ID, okay? And so this goes through the whole table, and so Audio Slave had 10, 11, but also album ID 271 belongs to Audio Slave, so that, you know, they indeed have 3. Okay, this is this gets a little bit strange. Okay, so here we created this, right? We created this table which says how many albums did each artist produce. Okay, now you might want only the artists that have produced a certain number of albums, right? Like who's very prolific. All right, so here you can do the same kind of thing, right? So I said select artist name count as album count from albums. So this part is all the same as before, okay? This part's exactly the same as what I have up here. Select artist album, inner join, group by artist ID, okay? Select this and this from album, inner join, group by this, okay? But then to limit the results of this thing, just so that album count is over 8, you use the having statement. Okay, so you don't use a where. The where filters the individual rows in the table, but here we've aggregated them. Okay, we've aggregated them into this thing where it says this artist has this count, this artist has this count of albums, and so we use the having statement. Okay, conditionals on the group by have to be done using having. So I run that. And we get Led Zeppelin, 14 albums, Metallica, 10 albums, Deep Purple, 11, Iron Maiden, 21. 21 albums. That's a lot. U2, 10 albums. Is that true? How many albums by Iron Maiden? Okay, I believe it. Wow. Look at that. 2017. Is there something newer than that? This is impressive. 1980. 2015. Oh, a bunch of live albums, compilation albums. Okay. Good job, Iron Maiden. All right. Okay. You can do this is silly, okay? But you can do mathematical operations within the thing and just title them whatever, right? So here I'm going to take artist ID, and now I'm going to just do artist ID times 2. I don't know why we would ever do that, okay? But you can do computations on these things, right? So we can do something like this, right? Artist ID times 2 gives me the magic number, okay? Let me see. I think you can do even, you can do stuff. So let's say we're going to go with the album table, okay? So the album table has 2 numeric columns here, okay? Album ID and artist ID, okay? And I can do album ID divided by artist ID, okay? As album artist ratio, which makes no sense, right? And then we would, I guess, what's the name of the thing? Title? Yeah. Okay, and so this is silly, but it can be done, right? So, oops, I need artist ID and album ID. The album ID is 4 divided by the artist ID of 1 gives me album artist ratio 4. This has no inherent meaning, right? Limit 10, we can say order by album artist ratio descending. Oops. think, okay. No? Hold on. There's something about having spaces in your titles. You're not supposed to do it. What am I doing wrong? Do I order by? Message column album. Did I do something wrong? It sees it as a, okay, that's what's going on. There's all sorts of rules about how you should name your stuff, okay? So I had a dash there and it was seeing it as a minus sign, okay? And so it was getting confused, okay? So generally, yeah, in your titles, when you name columns and stuff, they recommend no spaces, no dashes, things like that. It confuses the computer there. Okay. Look at this. Album/artist ID. Oh, it looks like it's doing an integer division. So how do I SQL float division? Let's see. How to get a float result by dividing two. Oh, you got to cast them. Look at this. Okay. How annoying. Okay. So I have to cast as float. Okay, there we go. Now we can do it. All right. So, we're not accustomed to stuff like this, okay? And we have languages that we're accustomed to R and Python being very nice about upcasting data types, okay? SQL is a little bit old school, right? Integers operating together produce integer results. So integer multiplied by integer produces an integer. Integer divided by integer actually will produce an integer. So if you want a float result, you have to cast them as floats, and then you can do the division and your result will be a float. So that's what you get. Okay, we'll end here today. I'll be here on Wednesday. I'll record the lecture on Wednesday. You can watch it. And again, if SQL, I don't know how interested you guys are in SQL. It shows up in a lot of job requirements, okay? And I would say your best thing for SQL is to just practice. And just like any other language, okay, whether it be a foreign language where you're speaking to people or a computer programming language, it's just one of those things where if you want to perform well, you've got to be using it regularly, right? So if you're going to have an interview and there's going to be a technical component to it, spend like a couple weeks doing some exercises and practicing, okay? There's going to be some other neat stuff you can do with SQL, things called common table expressions, stuff like that. We'll take a look at that on Wednesday if you're here. And so if you're not here on Wednesday, have a happy Thanksgiving. And if you do show up on Wednesday, I'll see you on Wednesday. So we'll end there.